This question means that we had an obtuse-angled triangle ABC and reduce BC until one of its perpendicular line can go through point A and make point D. Then the square on AB is equal to the square on AC plus the square on CB and plus twice the rectangle formed on CB and DC. Which makes this. And now let's prove it. First, we know that AD is perpendicular to DB, which makes triangle ADB a right-angled triangle. And triangle ADC is also a right-angled triangle, which means that we can get the square on AB is equal to the square on AD plus the square on DB, and the square on AC equal the square on AD plus the square on DC. And we all know that DB is equal to DC plus CB. And make this equation all squared, which makes this DB squared is equal to DC squared plus 2 twice DC times CB and CB squared. And replace the DB in this equation, this. And so we get AB squared equal to AD squared plus DC squared plus 2 DC times CB. And last, we can plus a CB squared. And we have that AC squared is equal to AD squared plus DC squared. And then replace again. And finally, we have proved that AB squared is equal to AC squared plus 2 DC times CB and add CB squared.